Well, welcome to 360 Yield Center. What a pleasure it is to have you come in, just rest your feet a little bit. Take a seat, and we're going to talk about the technology you see behind us running. So you see a 360 rain unit running. You know, it comes down to this. I've been saying all morning, if I was going to design the perfect farm, I would like to see a system where we could take water, because water is a huge factor or a huge minus. Let's be honest about it. It can raise a lot of corn, but if we have too much in the spring, it can be a real negative. And so being able to put water on and take water off, to me, is the secret. And so as I look at the rain unit in the back, we talk about putting water on. How do you and I design a system where we can come in and do what I call the ultimate? I don't think there's a farmer in the tent here that hasn't seen this at one time or another every year in our fields. You know, this is Tremont, Illinois, and we've had perfect rainfall all year, but at the same time we had 10 days without rain, 97-degree heat this afternoon when I'd taken this picture, and this field is in stress. And you can say, well, Greg, that's shirt-high pocket corn. I don't think stress at this level is a big deal. I guess I'm in the camp that I never want to see corn have a bad day. Soybeans, totally different. You can stress them and it adds yield. Corn, I'm always a little nervous about it, and I think we see what stress can do. This is a Pro Farmer Tour. This is Northwest Iowa picture, and you can see we pull back amazing amount on the tip. So as we look at the yields across the different states, you can see that we lost a lot of length here. I would just say this, when we talk about length, every kernel in length is worth 6 bushel to you. So in other words, if you abort 5 kernels, that's 30 bushel. And we're talking in a $6, $7 corn market, that's some serious cash. In this case, we lost what? 12 kernels. Pretty major drought. When I look at corn like this, there's 3 things that take off the tip. So you think about nitrogen, a lack of nitrogen will blow tip off. Drought obviously blow tip off, and then there's heat. Warm nights. 80 degrees is kind of the magic figure. If you have a night in a cornfield that's over 80 degrees the whole night, and we'll see this at times, don't we? I can think back to 2011, we had record heat in Illinois and Iowa. I think we put 30 nights in a row where it not got below 78 to 80 degrees at night. What happens? Well, that plant, when we think about nighttime temperatures all day long, it sits there and it's doing what? It's sitting, let's just draw it out here. So this plant's got these great big leaves, and we got the root system here. And the sunshine on these leaves, and it's doing what? It's designed to do what? Draw moisture up. When the sun shines on the leaf, it aspires, just like you do at the gym in the morning when you're working out, and that creates a vacuum. And immediately we start pulling up a massive amount of water and nutrients underground. 10 feet below ground, if you got, ever how high your corn is, you got roots under the ground. You got 11-foot high corn at home, you got 11 foot of root depth. Unless you and I do some kind of a tillage layer in here and we turn them all. But you know, we're gonna assume that you've got it figured out. So all day long as the sun's shining here on this leaf, it's loading nutrients in this corn plant. It's loading the Walmart shelves. And at night, when the sun goes down, it's designed, it starts to put in nutrients in the ear as long as it's below 80 degrees. So if your nighttime temperatures is 69 to 72, I like it. What's it doing? It's putting in kernel weight and depth, and we're adding a lot of yield. A kernel weight and depth can be as much as 40 to 50 bushel of your total crop. The end of the season. You won't find a better day than we had right here. Sunday morning here we had 2 inches. Saturday night and Sunday morning. Then what we have here right now is we have plants just sucking up water. And what's it's doing? It's adding kernel weight. And that's going to make a difference. That's going to really drive a number. This can make a huge difference. We talk in the industry 90,000 kernels to fill the USDA bushel basket. If it only took, because they're larger, 80,000, that's 28 bushel more. If it's 70,000, a really big kernel, that's 56 bushel more on your yield. And so you and I are in the field and we're taking kernel counts and we're trying to figure out what the size of the kernel is. This going to be a 90, an 80, a 72, a 75? And that makes a huge difference. And so those are things we think about. So taking care of this crop can really make a difference. So how this goes is a lot according to nature. But here's where Gregg is. When I'm planting, this is what I see. As I'm planting corn, I'm thinking the whole time this right here at harvest. And so when we think about the right population and things that are happening out, I want to see at least this much cob out of a corn. That tells me that I got the 34,000 ears here. It's telling me we're just right. If that was all the way around kernels, I'd tell you you didn't plant enough. Kick it up 2,000 more. If you tell me we're like this much blowing off, then we're probably too high. And you can look at this ear. This ear is talking to us, isn't it? What's this ear saying? It had stress. How do we know it had stress? Early in its life. I'm talking corn this tall. It's setting on how many rows around it's going to be. Plant breeders at Pioneer and Monsanto said it's going to be 20. That's where it starts or wants to be. And however its growing conditions are, it sets on. It's set on 18 until you see that black line, and then it scrambled. And you can see it scrambled right here, and it went to 16. What's the loss to Gregg? 20 bushel. Every row on here is worth 10 bushel to you. Length is 6 bushel, every kernel. Rows around is 10. So something happened early in this plant. It could have been a real cold snap. It could have been the wrong herbicide. It could have been the wrong tillage. It could have been a lot of different things that happened, but you and I need to kind of think about it. If I have an ear that has every kernel lined up, that's what I'm looking for. Where should this ear be on the plant? First thing I do when I go in the field, I see where my ears are on the plant. In other words, 7th leaf, 7th node from the top. That's the highest yielding. 1, 2, the flag leaf, count that as 1. 1, 2, 3, 4, 5, 6, and 7. If it's on 8, what's that tell you? We better look at your program. Something in there is messing things up. 8's just going to be lower yielding corn. So I'm thinking this. Then there's reality. I don't know how many growers I've had come in this week here in Iowa and say, Gregg, on July 4th, we had one of the top 2 crops I've ever raised on July 4th. And then it never rained. And I get it. And I've been there. Illinois is not that way this year. We're extremely fortunate. And so we're going to mess things up for you guys. So being able to put water on, in my mind, is part of this picture. Being able to take water off early on is a huge asset. And so when I see this tile running and I see the water coming off this field, it's telling me that I can come in early and get this field planted in ideal conditions. No longer I got to worry about, compaction and putting tracks in and, wet areas. So this is an 18-inch smooth wall tile we're just putting in. And it's a pretty extensive operation. This is a 240-acre field, and we got a high spot in this field, so I had to remove 7 feet of soil in the overburden to put the trencher down in. We're pulling it with a cat. We're putting in an 18-inch smooth wall as our main. And then we're going to pattern tile this 240 acres. And I got 30 acres in this farm. We just can't get a crop in. So I'm going to gain 30 acres for $1,000 an acre installation. So I often sit here and I think, let's just take this father-son here. Do they need more ground, or do they need to take the ground they already own? I don't know where you are in Iowa, but we're in a, if there's a lot of money in the area, it's over $18,000 an acre right now, and it makes my eyes kind of cross. And I'm like, I don't know if I want to play that game. So should they just invest more in the ground they already own and raise yields by 50 bushel, or should they buy the next farm? And that's the question you have to answer. But for me, this is a no-brainer. When you see it this way, we got to drain it. Too many years, this farm, year after year, you see standing water in it. It's time to put the tile in and take care of it. You can see all the water in the background. But I'm thinking more about getting it done right early. What I mean by early, that first week in April, we like to plant beans in our farm. Why do we like to plant beans in April? Well, because there's a huge yield response. If we can get out there on April 2nd, huge yield response, 12 to 15 bushel on soybeans over anything else I've ever done to them. I've tried starter on them, I've tried sulfur on them, I've tried the magic in a bottle on them, I've tried nitrogen on them, I've done everything from A to Z. I finally just figured out, Gregg, you just put some seed treatment on, get a level, and do that, and get them out there as early as you can get them. So we start hard the first week in April, if it's fit. What makes it fit, Tile? Is that 12 to 15 bushel real? Yep. That's 5 years on our farm. I've never raised 90 to 100 bushel beans on May planted beans. Maybe it will this year, I don't know. And so we're saying, what does it take? This is one of our fields. It's a 92-acre field. It's pattern tiled this year in Illinois. What don't you see here? You don't see one drowned out spot. You don't see one bad spot in the field. Illinois is from fence row to fence row, high year count, no problem spots. As I came up 30, I didn't have to have imagination to see any problem spots. And when I come up on 80, I was looking across your fields here in Iowa, and we got what, 5 acres here. This year, will it be the highest yielding corn ever? Probably not. Will it be the highest field averages ever? Yeah, I think so. And so what we're talking about is how do we design? How do we help corn? What's corn can it go to? Well, we know, like it or not, we know it can yield 600 bushel. Dave Hewla out there in Virginia has yielded twice over 600. He tells me, Greg, he's a friend of mine, he says, Greg, the day is coming when I'll raise 800 bushel corn. You know what really stinks? It's the same stinking numbers I plant. And if I hit 300, I'm calling home, I'm telling Cindy, I can't believe it, it's fantastic, and I'm all excited, and I'm not even halfway what it could be. So that conversation happened all the time around the kitchen table, and I'm telling the boys, I said, what's it going to take for our family to make a radical difference in our production? I mean, I get really excited at Y drop when it adds 16 to 12 bushel just by putting nitrogen in the right spot next to a root. That's a real number. I really like that. $6 times 12, that works for me. But I said, I'm talking 35 to 50 bushel in one step, just one step. How do we get 50 bushel? Well, around the kitchen table, it's like, Dad, it's going to have to be water. Nitrogen is great, but it's got to be water. And so we started and we started to say, well, what would it look like if we would come out in a field, and this machine obviously has to be autonomous because you're not going to ride it. If you've ever run a drag line on manure in the fall, you will go out of your mind. You put a young guy in there with an iPhone, and he just watches YouTube all day long because, I mean, it's on auto steer going 0.4 mile an hour, and it'll drive you crazy. And that's what this is running. This is running less than a half mile an hour. You're not going to drive at 724 because it's going to run around the clock, and it's going to live in 160 plus acres, and it's going to put on a ½ inch every week. And so we said, all right, we're going to water at the base of the plant. I don't want to take a pivot over the top of a cornfield on an afternoon like this. If I run a pivot right now at home, what did I do to that corn if I put 55-degree water on it? It just like, and it just shuts down. I lost, how much will a cornfield pull up in one day? Anywhere from a 3/10 to ½ inch of water a day comes out of the root system. Think of that. That's amazing. What's coming in of water? Nutrients. And so if we're going to maximize yields, we've got to keep that plant running hard every day. So when we run a pivot, it shuts it down for a whole day. So I told our team, we're going to run it at the base. And we're going to water down at the bottom of the ground. And we're going to put it in a band. So there were some requirements. I talked to our engineering team and I said, guys, it's no matter what the grower's field shape is, we got to water it. If he has a big old gully in here or trees in here, I don't care what the shape is, we're going to water anywhere where he plants. So it was very easy for me to draw on the whiteboard. Where the planter runs, we're going to water. And they all look at you like, well, Greg's gone crazy. And that's happened a lot, so that's nothing new. And so I said, any field shape we're going to water across the Midwest. My goal is to water 70 million acres till we're done. So I'm going to have to hurry, aren't I? Because every day I get a little bit older, but I'm excited about what the potential is. And the second, as I said, we can't require much water because there's a lot of places that they can't get 1,000 gallons to run a pivot. You know, at home, we're running anywhere from 1,000 gallons to 1,100 gallons per minute to run a large irrigation system. Quarter-mile arm running around in a circle takes a lot of water. I said, no, 250 max. That's the max we need is at 250. I said if they have 175 to 125, we're going to water their corn. And so this system's much, much cheaper. 8-inch casing, 25 horse motor, residential driller instead of an irrigation driller. So he'll come within 4 or 5 months instead of 1 year. You know how that goes. You try to get a well driller in. And so it's all part of the system. And so that's what's out there. Obviously, surface water works in Iowa. Creeks and rivers and reservoirs. And then, of course, the livestock industry. Man, have we lit them up. This was designed to say, can we pump out of dairy lagoons and hog lagoons? Can we water corn? So it's got to be simple. So we provide to you, when you buy a rain system, an RTK system, 2 receivers. They're going to be mounted on there. Wherever the planter goes, we're creating a path. Let me draw it out for you, what it looks like. Very simple concept. We never let go of the hose. So I told you we can do any shape, so then Greg draws a square field. So we're going to have the well out here. Out in the center, we're going to put a hydrant. The rows are going to be planted this way, all right? We'll put a PVC pipe underground. Let's just say 6-inch PVC. That's going to carry water, nitrogen, sulfur, manure out to the rain system. We're going to hook it on, and it's going to make its own path. We call it the 50-yard line, okay? We plant it all the way through the field, and it's RTK, so it's going to do the same path every time. It's going to come out and turn. So in other words, it's going to turn. It comes to the east, and it's going to turn north. It's going to do 1/4 of an inch on the way out, 1/4 inch on the way back, turns its butt toward the well, then it goes down, and now you start to see the pattern. And it's just going to cover the whole field. You say, well, how are we going to get the end rows in this? Well, that's not a problem. The first thing we do, we leave the well, we just come down, we water that section, and we water this, come back, and then we go up here, we water this end row, and we water that end row. So we're going to band it by design. I said we're going to have low water. I don't know why we need to water the whole profile. Let's just put the water where we need it, right around the root system. So this is 15-inch bands. So we're watering half of the surface. When I tell you 1/2 inch a week, what I'm really saying is the plant sees 1 inch. That's 1 inch of water. That's 1 inch rain every week around that plant. And you realize how God created corn. This is exciting. So you look at this. What has happened to the temperature right here? If I stick a thermometer in out here, it's over 98 degrees, the soil temperature. Where we have watered, it's 74. What's in here? Well, it's the way creation is. It's an amazing thing. We have the good guys, a lot of them. They're in Iowa, they're in Nebraska, they're in every cornfield that's out there. There's microbials. So let's just talk about them. These guys have one job in life. These guys are supposed to be eating residue, and what do? They give you free nitrogen. So they come out here and they eat all the residue that's in the field. Soybean residue, corn on corn, the stalks, the cobs, the shucks. They're digesting them down, and they give us free on how much? A lot. How much in Gregg's field? I measure it. 80 to 100 pounds of nitrogen. Free. This year, in the coming year, nitrogen's going to cost you 80 cents. That's $80 an acre to manage Mike and his team, the microbials. What do they need? They need the right temperature, the right moisture, and a food source. Well, they got the food source. That's out there by the tons. How many of these guys are out there? Do you know? Science will tell you. 36,000 pounds per acre. Let's put it in Iowa terms. 36 1,000-pound steers. Okay? If your soils are in balance. What I mean by balance, pH. What happens if your pH, you say, man, we have so many expenses, we're not going to lime this year. We need lime, but that's one thing we can cut. No, I wouldn't cut it. A 6.5 pH, this is how many pounds of the good guys you got on a 6.5. If you let your soils go to 5.9, how many do you have, do you think? 36. If we got 36,000 pounds, how do you think it goes to? You shot all these guys, you only got one steer left, 1,200 pounds of bacteria and a 5.9 pH. So those guys are no longer, if you got a 5.9 pH, well, first of all, I would know it if I walked in your field because I can see last year's husk. If you go in a neighbor's field that's not liming and you see the husk, the husk and the hair off the ear itself, you know that it's low pH. So we're creating an environment here that's going to make a difference. So it comes down to saying, well, you watch it run here and you say, okay, that's a pretty cool shot in head-high corn, but what's the real effect? Remember that picture I showed you of the stress? Right across the road, there's a rain unit running. Look at the difference. This corn is doing what? It said, Greg, I'm in trouble. And it's doing what it's supposed to do. It was designed to curl up and protect itself. So, but what's happening here? When it designed, look at the sunlight that's on the ground. What do you think's happening here? I mean, it's going backwards in a hurry. The heat. Where you and I see sunlight in the ground, we lose the equivalent of an inch of water a day. All day like this, that took out of this profile an inch of water. This guy over here could only take out at the maximum a ½ inch when he's pulling. So you should put more corn plants in. But look at this corn over here. And so where we have the rain checks in this field, we grew 12 inches more plant mass where we watered. And I'm really excited about the potential that we got. So let's look at where we've been in the previous. This is a check where we had rain running in this field. You can see it went this way. You can see this is nature. If we go here to the yield map, you can pick it up. You can see where that lower production soil stopped right on the row. That's where the rain ran. And then you can start to see it starts to pick up again up there. And you can see as it comes through what the effect is. So in 2 years, we've raised 52 bushel more average. So we're meeting Dad's requirement. I'm telling the boys, you're doing good. I'm not going to sell it to you and say, you buy rain, you're going to raise 50 bushel more. I think you can. I think I've seen 75 bushel, but at the same time, what's your year like? So we need to be careful. How about soybeans? I get this question all the time. Greg, I got a 160 acre field. I'm running rain. I put it in corn. Next year it's going to go in the soybeans. Do I move rain to the neighboring field? What do I do? And so I can show you 1 year's of research. This field here had 4 3/4 inches of water. We did 10 passes in there at 4/10. Okay? And you can see 2/10 on the way out, 2/10 on the way back, and the yields are crazy. They're way too high. You look at it and you say, boy, I don't know. That's a struggle for me to justify. When I was harvesting them here, you can see me harvest them, I couldn't see much difference. We weighed it, that's 9 strips, 9 trials across this field. I can tell you where I think it is from a farmer's perspective. Doesn't mean I'm right, I'm not an agronomist. So this field was what? It was planted early. I already told you Greg loves planting early. That field was put in on April 9th, okay? So on April 9th, we're in here planting it. We know what, on early beans, it's all about the night length. So if you and I drew a chart, this is June 21st. This is the shortest night of the year. We all agree? That's solstice. I mean, we can argue about it, but so if you and I can plant up in here, let's just draw a line in here. I'm going to say about May 4th to me is the line for Illinois where I live. After that, as the nights get shorter and shorter, it's not going to flower. A bean plant's not going to set flowers on until over here. It's the night length on the leaf that drives protein that makes them flower. So anything I can plant before the 5th and 6th of May, we're going to put flowers on. Where we put flowers on, we also put pods. So when you look at up there where my finger is, we had flowers and pods on the very, very bottom of that plant. And you can see them right here. There's a soil line, pods touching my finger. So you got to have a draper head that you can pitch your feeder house. You got to get it really low to capture it. When I went in where the rain hadn't ran, we had aborted doing just a normal summer. I had lost those lower pods. Is that where it came from? I don't know. I'm guessing. I think it is. And so those are things that we think about. I just wanted to give you the information to think about. When we designed rain, we said there's definitely a need to put livestock manure. And this doesn't look like pure water because this is straight dairy manure coming out of a stage 2 lagoon on a cornfield. And so I said from the beginning, guys, we have to think about the livestock guys getting a huge target on our chest. We have hog manure and we have a dairy. And I mean, we are the problem. Any place you open in the news, we're getting heavily regulated. All of us have manure plans in Iowa and Wisconsin and Ohio and Illinois. We're regulated. They come in and they look to see what you've done. And I just smile. So we're saying, when we started with rain, could it be that we could put manure on in crop season? To me, that's where it should be applied. So we took the rain machine and we designed it with that in mind. And we said, look, you can see that this little machine, you hear that little engine running? That's a little diesel engine. That engine uses a half a gallon an hour of diesel fuel, okay? That's a gallon per hour. That's a 300-gallon tank on there, so every 600 hours, we have to load the tank. 300-gallon we're carrying on board. So, and it's smart enough, it's not going to run out in the back of the field. It's got a computer mind. It's going to stop up by the road so you can fill it. It knows that. So we designed it. You can hear that motor running. We're designed that. It's an all-electric machine. It's got DC motors. This DC motor is turning this manifold, and we got a manure knife in there, and you can see these are 0.6 diameter holes, a little less than 3/4 of an inch, and this blade is spinning with heavy blades, and we're chopping any manure that's giving us trouble going through the orifice. And so we're screening at the pit, and then we're pumping manure in with the water, and it comes to the machine, and we're going through. So in Illinois, here's a picture of the hog buildings that we work with. We get the manure. You can see us parked here. We're pumping out of sump 1. We're pumping into this semi-tanker. He's going to go 25 miles to our rain field where I have a frac tank. You can see my well is right here. You can see the casing. You can see my nitrogen tank. You can see all kinds of other goodies that we're pumping in the water stream. Now we have a 2-inch line coming here, and we're pumping it in right here in this T. We're pumping in manure. So we're going to put hog manure on with water. And so that's 560 gallon of hog manure per acre going on with this pass in V6 corn. You can tell it's manure because you can instantly see the suds. And you can also probably put your hand underneath there and smell it. It's interesting to me. With dilution of water, the smell was really different. In the same way on the dairies. I'm watching this of interest. Would this stop Gregg from getting all the nasty texts when we apply manure? I don't know. We'll find out. So it's things that we think about. We're up in Ohio at this dairy. A really neat family, a lot of cows. This is just one of their many sites, 1,200 cows. They're right up by Lake Erie. So the government people, I was up there and put a day on, all the county extension, all the DNR people, you know, H2 Ohio is what it's called. They have a program. The governor gave them $110 million to help farmers figure out how to put manure on and not pollute the lake. So this dairy has stage 1, stage 2, and stage 3 lagoon. He is looking to have a rain unit, and he says, Gregg, I'm looking at a rain unit on this 160-acre field. You can see the dairy over here. And he says, I want to take stage 2 dairy manure, pump it out, and put it on this cornfield. And so, kind of interesting. So the boys showed me this field and said, this is where we're going to go in Ohio. And I said, really? They said, the guy is fantastic. I said, I don't doubt it, but there's a problem. He's got 2 windmills and 4 transmission poles in the middle of the corn. I said, wow, the first year out, that's going to be interesting to see if we hit any of that. Of course, we haven't. They laughed at me like, Dad, we got it figured out. I said, okay, let's go. So the rows are running this way. You can see where the hydrant is. So it leaves this, it comes down, it turns to the right, goes, comes back, and you can see here. So he gave it a pretty good mouthful. He's been giving it water. The 5th pass in this field, he put on 6,500 gallon of stage 2 straight dairy manure right out of the lagoon. So his manure plan in Ohio lets him put on, according to his soil test and the manure test, he can put on 13,000. That's his maximum per acre, max. He just put 6,500 on in one splash. I said, Trent, let's go 4X instead of 2X. Just my feeling is, and we'll do water in between. We'll water that in. I'm just more comfortable spreading it out in multiple times. It's surprising how close you can get to the machine before you smell manure. Within about 15 to 20 feet, walking behind it, you can, as you get closer and closer to it, you can start to pick it up. We also got a machine in Wisconsin at a dairy. 1,700 cows, a Holstein, double S, Schmitz family. Once again, delight to work with. Very, very patient people as we bring in this new technology. Here's their lagoon pump. It's actually the screen where you have a hose running into this screen that's rotating, so we're filtering it. It's coming to the shoreline, so that's out here. It's coming up. We got a PTO because we couldn't get the electric pump in time. So next year, this is all electric. It's not going to have a tractor there. You can see it out in the silage corn. So his in Wisconsin, he's only allowed 10,000 gallon according to his manure plan. This is Wisconsin. And so he's putting on 2,500 gallon there. He's going to do a 4X pass. So we took and went, interesting, we designed a rain to run out on the alfalfa field, so you can see the farm back here. So he's got 85 acres of alfalfa here, and we're spreading that 2,500 gallon the day after the chopper went through. So they cut this alfalfa, they merged it, they chopped it. The next day we're running in here, and you can see what it looks like. We're getting a very nice spread. And the Wisconsin people say, well, if you're going to go on alfalfa, they're saying you can go to 20,000 gallon. They 2X it because alfalfa utilizes phosphorus twice as much as corn. So this is where we're at today. We've designed a unit that takes any shape of any field. It takes low water. Hopefully we can take and handle manure so we can increase, you know, my hog system there, I'm allowed to put on 5,600 gallon. Let me just draw it out for you, because this drives me nuts. We all admit that nitrogen's too high in price, right? We can all gather around that. We can say fertilizer's too high. At 5,600 gallon per acre of hog manure, that's 240 pounds of nitrogen. Okay? That's in the fall. When it comes spring, what do you think my agronomist gives me for value? 120. I'm like, what? Yeah, that's all you're going to get credit for. Well, I just lost in an 80-cent nitrogen market, or 50 cents even. I lost what, $70, $80? More than that. And so if I can come in and put it in this crop at the proper time, I'm hoping I can get like 90% efficient. I'm hoping I'm going to be over 200 pounds of N. So those are things that we're thinking about.